In addition to all the trig identity that we did last class, just quickly, I just go back and refresh your memory. Last class we said make sure you know that what? Secant theta is equal to what? 1 over cosine theta. Cosecant theta is equal 1 over sine theta. Now, tangent theta is equal to what? Sine theta over cosine theta. We also said cotangent theta equals 1 over tangent theta, which means you take the tangent, you flip it over. That's cosine of theta over sine theta. Again, this is not really today's topic. We'll add today's pieces to it shortly. I said have a sheet of paper with all these identities on it. It will make your life easy. And if you recall, we also said sine squared theta plus cosine squared theta is always equal to what? To 1. And you can take that equation, derive 2 more out of it. How? If you divide every one of these terms by sine squared, you will have what sine squared over sine squared? 1. What's cosine squared over sine squared? Cosine over sine is cotangent. That'll be cotangent squared theta. And what is 1 over sine? Cosecant, you square it. And if you take this equation and divide every one of them by cosine squared, what is sine over cosine? Tangent. That will give me tangent squared theta. Cosine over cosine is 1. 1 over cosine, which is secant. I said make sure you know these for the last homework assignment, for the previous section. I'll put a line going through it. Today we're going to add more to that list. We're going to talk about the sum and difference formula. What do I mean by that? If you have sine alpha plus beta, that's a sum. There's a trig identity for that that says, oh, that's equal to sine alpha cosine beta. When this is a plus, this is also a plus. Cosine alpha sine beta. What about when this is minus? The difference here. It's the same thing except that sign is negative. So that's what? Sine alpha cosine beta minus cosine alpha sine beta. So in a lot of math books, instead of writing this twice, I'll try to use these markers. I know they squeak. They'll combine them into one. They go sine of alpha plus beta is equal to sine of alpha cosine beta plus cosine alpha sine beta. And for subtractions, instead of rewriting that one more time, they'll do this. They'll go, when this is minus, you put a minus here. So when this is a plus, you'll see a plus. When this is minus, you'll see a minus. So they make them just one. They write them only once. We also have one for the cosine. The cosine of alpha plus beta, the cosine of alpha minus beta. And we have one for the tangent. So let me write the cosine. I'll go on a clean sheet of paper and I'll do the cosine. I'm just waiting to finish for you to finish writing. Then I'll move forward. Sometimes I get complaint on the video, can you move faster? I don't know, I'm watching the class, making sure you have enough time to write the stuff. Now let's look at cosine. Cosine alpha plus beta. Notice the sign here. When we have the sign, it's sine, cosine, cosine, sine. These are different. Sine, cosine, cosine, sine. For the cosine, it's different. Cosine, cosine. Cosine alpha, cosine beta. And when this is a plus, this is actually a minus. Sine alpha, sine beta. So for the cosines, cosine, cosine, minus, sine, sine. And again, when this is minus now, it's cosine alpha, cosine beta, plus sine alpha, sine beta. Again, most math book will write that in one. They go cosine alpha plus beta is equal to cosine alpha, cosine beta, minus sine alpha, sine beta. And when this is a minus, this is a plus. So when this is a plus, that's a minus. When this is a minus, that's a plus. I don't know if you can tell that's a red color. Does it show up as red?
Yeah.
A little bit? Okay. So when it's plus, it's minus. When it's minus, it's plus. And we have one for tangent, then we'll start using them. Let's look at the tangent. And we'll do some examples shortly. Tangent alpha plus beta, that can be written as tangent alpha plus, so the sign matches here, tangent beta over 1. The sign here is different, it's backward in the bottom, minus tangent alpha, tangent beta. So the top sign matches, but the bottom one, it's opposite. And when it's a minus there, it's tangent alpha minus tangent beta over 1 plus tangent alpha, tangent beta. Again, if you want to write them as one equation, tangent alpha plus beta is tangent alpha plus tangent beta over 1 minus tangent alpha, tangent beta. I'll make the t's look like this because that looks like a plus sign. Yep. Okay. And what happens when it's a minus? When this is a minus, where's my red marker? Right here. When this is a minus, this is a minus, that's a plus. So in a lot of math books, that's what you see. You see this, and you see the other one. They combine them into actually 3 equations instead of 6 of them. They just write them 3 times. Now, I'm just going to go to Google and find the unit circle. I don't know if anyone has a copy of that or not. Did I give you a copy of it? You can actually go to Google and just type in unit circle, and you'll have that chart. I'm putting it on the screen. Can't see it on the document camera, but if you look at your computer there, you'll see it. Well, here we go. Notice we have the sine of pi over 6, pi over 4, pi over 3, that's 30 degrees, 45 degrees, 60 degrees, 90 degrees, and so forth. We don't have the sine of 15 or the cosine of 15. So let's say I came in, I asked you a question, I said, there's your quiz question. One question on this quiz and that's it. Can you tell me what is sine 15 degrees? No calculator. And what is the cosine of 15 degrees? No calculator. And what is the tangent of 15 degrees? Again, no calculator. Now we got a problem. Because you look at the unit circle, you have the 30 degrees, the 45, the 60. You don't have the 15. You can see on the screen, right? Pi over 6 is 30. Pi over 4 is 45. Pi over 3 is 60. So how would I do that one? What you want to do is take the 15 and rewrite that in terms of something you know. 15, it's either you can use 60 degrees minus 45 or 45 minus 30, isn't it? So it doesn't really matter which one we use. If I use 45 degrees minus 30, isn't that 15 degrees? Now I can use sine alpha minus beta. Remember, we have that identity that says sine alpha minus beta, because that's what you have. You have a minus here. Should be sine of alpha cosine beta minus cosine alpha sine beta. We just did that one. Right here. I'll put it back there quickly. Sine alpha minus beta, sine alpha cosine beta, minus cosine alpha sine beta. So I'm taking advantage of that one. My alpha in this example, what's alpha here? For this example I'm doing. 45 degrees. And what's beta? 30 degrees, yes. So I'll plug them in now. You go, oh, that's the sine of 45 cosine 30 degrees minus cosine 45 sine of 30. When you look at the unit circle, the first number you see is your cosine, the second one is your sine. So let's look at the unit circle, and I wish I have a printout of one here. I don't have one to put on the screen. I'm looking to see, sometimes I throw papers here and maybe one floating around. No, I don't have one. Let me look one more place. Not really. Nope. So sine of 45, that's pi over 4. That's the second number. The square root of 2 over 2. Cosine of 30 degrees, that's the first number. The square root of 3 over 2. Minus the cosine of 45, the first number. The sine of 30 degrees, the second number. That is the square root of 6 over, notice the bottom is going to be 4 for both of them, so I can just do the math here in one step. What's the square root of 2 times the square root of 3? Square root of 6 minus, what is the square root of 2 times 1? The square root of 2. And that's the answer for the sine of 15 degrees. If they say, give me an exact answer, that's your answer. Now, if you want to verify that, you take your calculator out. Let's see if we did it right. And I don't know how to use this one. I'll attempt to use it. Parentheses. I don't know if you can see it. The square root of 6. I got to find the square root. Oh, square root of 6. Oh, I got to get out of this. Delete. How do you get out of it? Maybe push the arrow to the right. Here we go. Minus the square root of 2. Get out of it. Push the arrow. Close the parentheses. Divide that order of operation divided by 4. Says do what's inside the parentheses and divide it by 4. Shift. Oh, answer degree. I don't want the exact answer. I want approximation. I don't know how to get the approximation. Is it Alt maybe? I don't know. Mode. Do I have exact anywhere on the mode here? Anyone sees exact? No? Well, this shift, it gives me degrees radian. Shift answer. Or shift mode? No? So if you have a calculator, plug it in. And it should give you that answer. I just don't know how to do it on this one. Let me try. Nope. I'm just hitting answer again. Shift answer. Nope, that's going to change degrees to radian, I think. 1 is degrees, 2 is radians. Let's make sure. I'm going to put my calculator in degree mode. I don't need, not for answer. So that doesn't do me any. Oh, what do you know? Or maybe not. I don't know. I don't know if that number is 0.2588. I pushed some button, God knows. Is it?
Yeah, that's the first one.
That's the answer for the whole thing. For this one?
Yeah.
Is 0.2588?
Yeah, that's the first one.
Everyone got it? No? Doesn't matter. You're not really doing radian degrees. It will not make a difference. Oh, yeah. You got to be in degree mode. Oh, you know what? I don't think I was in degree mode to start with, because I got this calculator. I forgot to put in degree mode. I don't know how to do it.
Same thing as the degree.
1. Okay. Can't be the same answer. I need different calculator. So, huh? Sure. As long as it's not Casio.
Nope.
Oh God. Oh, that's TI-84. So here we go. The square root. There we go. Parentheses. The square root of 6. Wow, this is really nice color, clear. Minus the square root of 2. Divide. It's amazing. Technology today, the display versus what I used to use. The answer should be, again, are you in degree mode?
Yeah, that's it. No,
So were you in mode before? Let me see. Where's mode? Yeah, you were in degree. Yep, good. So that's the answer. Yep. Quit. So that's the answer. 0.258819045 The reason I'm doing this because I'm going to have the calculator give me what is sine of 15 degrees without doing all this work. Let's see if it gives me the same answer. Here we go. Clear. Sine 15 degrees. 0.258819045 Did we get the same answer? Here's the promise. Like, why do all this work if the calculator is going to give you the answer? Because we're going to ask you for the exact answer, not the approximation. This is an approximation. So if you type in that answer, you definitely got it wrong. They want to see that answer. So you have to know these actually properties. Thank you. Let me do the cosine now. I just got to erase a few things and push it down, then I'll do the tangent. because I can't fit it right there. I have a white out, so not a big deal. So let me do the cosine of 15 degrees. Again, I don't have a 15 degrees on my unit circle. I'm going to write that 60 minus 30 instead of 60 minus 45, just to be different. Because I have the answer to both of these. I could have used 45 minus 30. It won't make a difference. So what's the cosine of 60 minus 45? Well, again, I have to use cosine alpha minus beta, which is cosine alpha, cosine beta, and this will be a plus sine of alpha, sine of beta. What is alpha in this example? Anyone? Alpha is 60, yes. And what's beta in this example? 45. So this will be cosine of 60, alpha 60, cosine 45, plus sine 60, sine 45. Look at the unit circle. Cosine is the second number. Cosine of 60, the square root of 3 over 2. Cosine of 45. Oh, cosine. Nope. Cosine of 60 is 1/2. I'm looking at the sine. Cosine is always the first number. Cosine of 60 is 1/2. You see the unit circle? The first number is 1/2, right? That's pi over 3. The 45, pi over 4. The first number is what? The square root of 2 over 2. Let's look at the sine of 60. 60 is pi over 3, and the sine is the second number. It's the square root of 3 over 2. And the sine of 45. 45 is the second number. Pi over 4. Look for the second number. And again, you can make that one equation. The bottom is 4 for both of them. That is the square root of 2 plus the square root of 6. So now we have the sine. And now we have the cosine. We got both. The next question, what's the tangent? What is the tangent of 15 degrees? Now I can go ahead and use the equation for the tangent. Where is it? I can go ahead and use the equation for tangent and make it 45 minus 30 or 60 minus 30. I can do that, but that's too much work. Why should I do that? Why not take advantage of what we did last class? What's a tangent equal to? Sine over cosine. Do I know the sine of 15? Yes. Do I know the cosine of 15? Yes. It becomes algebra. So here's tangent 15 degrees. It is the sine of 15 degrees over what? The cosine of 15. So when you write that, what's the sine of 15? The square root of 6 minus the square root of 2 over 4. And what's the cosine of 15? The square root of 6 or 2, it doesn't matter because you have addition. It doesn't really matter which one you write first. When you have addition, you can flip them, right? The 2 first or the 6 first. And now the rest is just algebra. So that's equal to the square root of 6 minus the square root of 2 over 4. Instead of divided by this, we can change it to multiplication by the reciprocal. The 4's will cancel each other out. And that's my answer. But that's not acceptable to our software. Why? What is wrong with that answer? No math book will leave the answer like this. Not just the software. They don't like to see square roots in the bottom. That means you got to do what? Rationalize the denominator. How do you rationalize the denominator? You multiply by what? What do you want to multiply by? Square root of 6? Plus or minus? Try again. Minus. You'll see why minus in a second. This is called the conjugate. Conjugate. Because you don't want to see a square root in the bottom. So let's see what will happen if you FOIL the top. Remember, you FOILing. What is the square root of 6 times the square root of 6? Just 6, or the square root of 36, which is 6. What is the square root of 6 times negative the square root of 2? That will be a negative the square root of 12. Now the next one is this one. Negative the square root of 2 times 6. Negative the square root of 12. And the last one, negative times negative, that's positive. The square root of 2 times the square root of 2 is the square root of 4, which is 2. When you multiply a square root by itself, you lose the square root sign. Now let's FOIL the bottom. What is the square root of 6 times the square root of 6? That's a 36. Square root of 36, which is 6. This will be a minus the square root of 12. This will be what? Plus the square root of 12. And the last one will be minus the 2. The reason we switch signs, so these two will cancel each other out. You can see one is negative, one is positive. That's why we switch the sign. If you don't switch the sign, you'll have plus and plus, and you never get rid of the square root in the bottom. 6 minus 2 is 4, so the bottom is 4. What about the top? What's 6 plus 2? 8 minus 2 sets of these. 6 minus 2, which is 4. Simplify a few more steps and you're done. 8 minus 2. The square root of 12, I can write that what? 4 and 3? And what is the square root of 4? 2. 2 times 2? 4. Can I factor anything out of the top? You can take a 4 out. If you take a 4 out, what's left? 2 minus the square root of 3 over what? 4. And notice now the 4 cancels the 4. And your solution for tangent 15 is 2 minus the square root of 3 over 1, which you can write that 2 minus the square root of 13. You never want to write the answer over 1. You just want to write it 2 minus the square root of 13. It wasn't like boom, boom, like 2-second problem. You can see some of these take a little bit longer to do. But that's why we like, they come in handy when you have, what is that square root of 90, for example, because 90 is 60 plus 30, or 45 plus 45. The same thing with the cosine. Let me try other examples and pick some more examples and see what we're going to do. A lot of times you look online or in a math book and they'll say, you know what, sine of x plus 180. Simplify. Simplify. So they'll give you this, but in this case, I'm going to say simplify this. You know what? I don't like the way it looks there. I'll change the question. Just simplify. I was about to do something else, but sine of x plus 180. Simplify that. Tell me, what is that equal to? Notice that fits sine alpha plus beta, because you have addition there. Again, the rule for that is sine alpha cosine beta plus cosine alpha sine beta. So let's fill in the blanks. What's alpha in this example? Alpha is what? X, yes. And what's beta? 180. Put them in. Sine of x cosine 180 plus cosine of x sine 180. Again, you can look at the unit circle or your calculator, either one. We don't know what x is, you'll never be able to find the answer to it. But what's cosine 180? That's a negative 1. Cosine of x. And what is sine of 180? That's a 0. Now you multiply them. 0 times anything is 0, minus 1 times this. That's a negative sine of x. So you can say sine of x plus 180 is the same as negative sine of x. I bet you if I looked online for some trig identity, that'll be listed there. They don't show you how they came with this answer. They go, this equals to that. Well, how? This is the math behind it. Let's try another one. What is tangent? X minus, we didn't do a lot of tangents here, 180. That's equal to tangent x minus tangent 180 over 1 plus tangent x tangent 180. Now remember, tangent is sine over cosine. X here. So I'm going to use tangent, the identity I'm using. I already wrote it down, I guess. Alpha is x and beta is 180. I should have wrote the identity first, but I already put the values there, so there's no sense of rewriting all that stuff again. So here we go. There's tangent x minus. What's the tangent of 180? Remember, the tangent of 180 is the sine of 180 over the cosine of 180. Or you can go to your calculator and get an answer for that. I'm looking at the unit circle in my head. I know sine 180 is 0. Cosine 180 is minus 1. 0 divided by anything is 0. Except 0 by 0. So I know that's a 0. So if you plug in tangent 180, put a 0 for it. 1 plus tangent x times 0. Not the x times 0, the whole tangent. 0 times anything is 0. So you end up with tangent x over 1, which is what? Tangent x. I'll give you another example. Let's say we have one that says simplify. Sine, this is a fraction here, so make sure you have room. Alpha minus beta over sine alpha sine beta. Do we have a trig identity that does sine alpha minus beta? Yeah, right? That's sine of alpha cosine beta minus cosine alpha sine beta. Divide that by sine alpha sine beta. Now you can break that into two fractions. Sine alpha cosine beta over sine alpha sine beta minus cosine alpha sine beta over sine alpha sine beta. Look at each one, see if you can simplify anything. These two. These two. What's cosine beta over sine beta? Cosine over sine is what? Cotangent. What is cosine alpha over sine alpha? cotangent alpha. So when you simplify that, that's cotangent beta minus cotangent alpha. A few more examples, then I'll call it quit on this. Let me think. What is cosine God, I can't see this. Oh, let's see. I'm better now. Cosine 3x cosine 3x minus pi minus, the first one is sine 3x. Let's do sine 3x. Minus cosine 3x sine 3x minus pi. I want to simplify this. The question is simplify. I'm just looking at this and I say, you know what? Let me call 3x alpha. Let 3x equals alpha. And let 3x minus pi equals beta. Let this one be alpha and let this one be beta. Well, if you do that, this problem becomes what? Sine alpha cosine beta minus cosine alpha sine beta. Is there a trig identity that has this in it from today's class? Sine alpha cosine beta. Sine what? Alpha minus beta. Yes. That's what that is. So let's fill in the blank. That's sine. What is alpha equal to? 3x minus, what's beta equal to? 3x minus pi. So you end up with sine 3x minus 3x is what? Gone, 0. Minus a minus, that's plus pi. Don't leave your answer like this. If you can simplify your answer, always simplify it. What is sine of pi? That's a 0. So the answer to that problem is 0. Even if you have a calculator, you really couldn't do this on the calculator. What are you going to write? Sine 3x cosine 3x minus pi? Maybe if you buy a calculator for a couple $100, it might give you that answer. But an average calculator, you can't write that in it. So you have to go through the math the way we did and find that solution.
Do you hit a 0 every time you have a pi on your...
Well, that's unit circle. Sine. Sine of pi is always 0. Cosine of pi is -1. So I recommend that you print the unit circle. Go online, just find unit circle and print it, and just have it with you all the time. I wish I remember. I would have printed one for me too, you know. Or maybe I'll give you a problem like this. I said, hand in your calculators, everyone. Give me your phone, your calculator. There's your question on the homework or test. Simplify. Cosine 250 degrees. Cosine 70 degrees plus sine 250 sine 70 degrees. I got no calculators. What's the answer to this? Again, I see cosine, cosine, the same numbers. I go, let me let alpha equals 250 and let beta equals 70 degrees. I should be able to write this now as what? Cosine alpha, cosine beta, plus sine alpha, sine beta. Again, do we have trig identity that has that in it? That's cosine what? Alpha minus beta, right? And now you plug in the values for alpha and beta. That'll be cosine 250 minus 70. What's 250 minus 70? Is that a 180? Again, if you have that unit circle with you, you can look at the 180, and that's a negative 1. So the answer to that problem is 1. Last one, then we'll call it quit. I know these problems are lengthy, and I'm spending a lot of time on them intentionally because I think that's chapter 20 is the worst one in the book. I wish I recorded the first section. Simplify, last one. Tangent x minus y plus tangent x over 1 minus tangent x minus y tangent y. For tangent x, I mean. Oh, it is y. Should be tangent x. Yep. Okay, so I'm going to let alpha equals x minus y, let beta equals x. So that problem becomes what? Tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. And again, we have a trig identity for this. This is what? Tangent alpha plus beta. If you look at the notes, that's what tangent alpha plus beta is. Now let's plug in the value for alpha and beta. Alpha is what? X minus y. Add to it beta. Beta is what? X so what are you going to have? Tangent 2x minus y. And that's it. That's as far as I can go with it. And I'll stop here.